Welcome to the Extinction Level Event Podcast, Apocalypse Edition. I am your host, The Barrel. So, this time we're going to talk a little bit about all the big winter storms that are happening all around. Like the one we just had, obviously, when you hear this, won't be just had, but for me, recording this, that covered Florida in some snow and southern Louisiana. Places that you normally think of winter as I might need a light t shirt. So, I'm also going to be covering some factoids that I just kind of found both looking around for this information and adjacent to it that as I was looking up kind of jumped out at me. We're going to, we're going to look at all that kind of stuff. So, one thing I was looking at, here we go, is something that I was curious about. And I'm curious a lot about this because of how much we're going to turn Earth into this in the future is the Venus. And I was wondering because I have heard this, I've seen it repeated places, not necessarily places I would consider extremely reputable necessarily, but it's definitely made its rounds in the I don't want to say pseudoscience because it's not just, like it's fake science. It's maybe just exaggerated science sometimes for the sake of trying to teach somebody or wow them with science or something like that. But one thing I've heard a lot is it rains lead. And so I looked that up and it says, no, it does not rain lead on Venus. Instead, when it rains on Venus, it's actually sulfuric acid rain, which evaporates before reaching the surface due to the planet's extreme heat. I don't know all the different precipitation. I believe that it snows metal. I don't know if it's lead specifically, but I believe it's technically quote unquote snows metal. I believe that even that melts before it hits the surface, but like up in the high, like the ionosphere, it does not rain lead. I believe the closest it comes is it snows metal, I believe I have seen. I did not look that up specifically or other precipitation, just the lead thing. But I believe I saw that someplace. That's kind of as close as it gets to metal precipitation there. I also wanted to look up what some of the other atmospheres of planets, especially like the gas giants, which are mostly helium and hydrogen, which makes sense because that's, what would naturally form around a planet and not be produced by the planet. Which is why, we have the sun, because a lot of hydrogen and helium got together, mostly hydrogen, obviously. And, the gravity crushed it down and started fusion. So, sorry, I'm trying to go over it in my head at the same time I'm saying it, so I know I'm saying it right. But fusion gets started in the sun due to gravity and produces a star, whereas something like Jupiter, I believe, has to be like 10 times bigger, I think is what I saw. Is some number bigger. Like not a huge number, but not a teeny number either. Like Jupiter isn't like on the edge. Jupiter's like, it needs to be several times larger to have ignited into a sun. But it makes sense that it's kind of a mini version of what it takes to become a sun. That and the other two, Neptune and Saturn, all gas giants, are made mostly of helium and hydrogen. And to me, that's interesting because what I was looking for, because Venus is mostly carbon dioxide. And I don't believe Mercury has an atmosphere. I think it's just too close to the sun. I don't think it has. In fact, I believe I've read that I think maybe just Earth and Mars are the only ones who actually developed a magnetosphere. I don't know if Venus ever did. I don't think so, but that's something I could look up, obviously. But I think I read that the Earth is obviously the only one with an active magnetosphere. But I think it and Mars had magnetospheres, and obviously Mars is gone now. And without a magnetosphere, you're not especially this close to the sun, you're not really going to be able to keep an atmosphere. The thing with the gas giants is they basically are atmosphere. I mean that's what they are. So it's not that they have significant atmospheres; they just are atmosphere because they're gas giants. So the reason that that's kind of interesting to me is because we're pouring a lot of carbon dioxide in, but we're also putting a significant amount of methane in. Like I've looked at the other ones and it said it had trace elements of things like methane. But we're going to be the only planet in the system with a significant amount of methane in our atmosphere. So that will definitely be interesting in the future for us to be more Venus than Venus. Maybe it will contribute to us actually being a hotter planet than Venus, because Venus is hotter than Mercury because of the runaway greenhouse effect, but it's mostly carbon dioxide. And methane's actually more potent than carbon dioxide. So if we have a bunch of water vapor, which might just end up getting boiled off of the planet anyways, and methane, which is going to be worse than carbon dioxide, not to mention the other ones that we went over before that are even more dangerous than methane. All of that in there could make our planet even hotter than Venus eventually. Not as far as not as far as we would like. I did want to look up because a lot of planets have cycles, and I was curious. So I guess we should start with well, no, I want to start with this one. I was looking to see if Venus ever had like an ice age, and I don't mean in its entire prehistory. I just mean like as a normal part of its cycle. Obviously, it's not going to form actual ice, but something they would quote unquote consider an ice age because its temperature dips significantly for a while. You know what I mean? And then raises back up and dips and raises. And even if those dips never form actual ice or liquid water or anything else, but that it has that kind of a cycle. And it might, but according to this, Venus does not experience ice ages just because it doesn't get ice. No, I think it's taken my question a little bit too literally. I probably have to talk to a cosmologist. But yeah, so it doesn't. Because I was looking up because when I was growing up in school, I was always taught, and this was way before global warming was a thing or climate change or any variation. Now, let me be, you know, precise in saying this isn't before this kind of stuff happened because I was born after the industrial age, right? Even being born during the industrial age, you're headed that direction because that's what really kicked it off. But this is before it became something that was, I don't even want to say well known, but even, known outside of fringes of scientific knowledge. Like even if most of the scientists knew, most of them weren't saying anything. This was kind of uncorroborated evidence, kind of a thing where we knew it. Certain agencies had the proof and the understanding, but it wasn't so widespread that you were seeing papers come out like constantly about climate change and hearing about it on the news or anything else. Climate change wasn't even a twinkle in the eye of media at that point. So I wanted to be careful that it obviously was happening, but it wasn't really something talked about. And when I was in school, what was often talked about, and this could even have been propaganda against the emerging climate change talk, like that kind of information that was going to be coming out. This could have been like heading it off at the pass before it came out. So I don't know. Like, I don't know why these things happen. We hear all the time about crap that gets in textbooks in different places that shouldn't be there or has been altered or leaves important things out, colors things different. Like being taught all my life that Columbus discovered America. And later you realize Columbus never even landed on mainland America, that people had come here way, after obviously the great migrations that settled the Native Americans here. Like after that is what we're talking about as far as the discovery. Even though technically that would be the discovery, right? But we're talking after that. The people who were non-natives, although yes, the people who settled here originally were not natives. They came from other places, you know, came from Africa and Europe and a lot of other places there. That it depends on how you want to look at it. Were native to that area during whatever extended period of time you have to be in a place to be considered native. And then they had then moved here, right? So at that point, obviously, this was a discovered place, and those people were technically not quote unquote natives at the time. But obviously, we're talking more, and I don't even want to say white settlers specifically, but I mean, I guess that's kind of how we look at it. Although I don't know if a Spaniard would necessarily want to call themselves white. But yeah, so more let's say modernized people of more highly developed civilizations, and even that's going to depend on how you look at things, right? But even then, obviously, regardless of all that, Columbus did not discover America. That's just not how that worked. So, yeah, we have people like I think it was Eric the Red was somebody who talked about. Uh, I can't remember. There's been others who have been here to mainland America way before Columbus, but after the Great Migration that brought the Native American tribes here. So things like that were kept out of the curriculum back then makes you wonder about your curriculum. But the entire point, I mean, I went off on a bit of a tangent there, but the whole point was that back then we were taught that we were going to be entering an ice age, and not like the next year, the next 10 years, but that essentially had moved out of the ice age and we're kind of in the middle between ice ages, and the next thing we were going to do is start entering into an ice age. Again, this was a ways off, but that's kind of the next place we were headed. And reading this, it says the next ice age is unlikely to occur for at least 100,000 years due to human activity. But normally it would be in about 50,000 years. I would say ice age is unlikely to happen on this planet, period. Like we're past that unless we can really fix everything. And then the next 100,000 years, really? Not that far away if we're thinking about it. Obviously not in anybody's lifetime. But 100,000 years is not too far off. I mean, obviously that depends on the whole decline of the electromagnetic field and what some people are predicting is happening with that. If those things aren't to be believed, and it's like, yes, this is just a normal dip, like we have seen many times before. So it's definitely very likely to just be normal and not a big deal. And in that scenario, then an ice age is going to be the biggest danger that this planet is going to face since modern civilization has begun. And that can be very trying. It definitely isn't going to be a extinction level event. People will definitely make it through, especially people close enough to the equator that they'll definitely get cold, but they'll still be able to grow crops. They'll be able to have civilization. They'll be able to go outdoors. Life will go on. So now we want to talk, I think, a little bit more on what the main topic is going to be, and that is the cold snap that's been happening. And like usual, as I say, this isn't a news program. We're not going to go over the news headlines necessarily and talk about this happening in Florida and this, especially because you won't be hearing this when it's pertinent to you. The LA fires were a little bit of an exception. I wanted to kind of get that out then because wasn't information I was giving you necessarily about the fires themselves, but talking about the danger of the heat and the heat that's coming and what that means for more fires, and just kind of let's all be on alert. And I wanted to put that out while people were on alert of that. This is something that is happening now, but as I think I said last time, we're already in it. We're already kind of deep into the winter. You're either prepared for it or you're not at this point, to be honest. Some people are never going to be prepared because they'll think, well, that doesn't happen here. So, and you should never think that. You should think anything that can happen anywhere can happen here, even if it's never happened here before. It's called climate change, not climate just get a little worse, but not really do anything different. That's not what it's called. So, some of the things that are happening, and Secular Talk just brought this up. Honestly, I don't think it was this morning he brought it up. I've been working this week, so thank goodness, right? Back to work. So I've been trying to do some catch up on some of his videos. So I watched the video this morning and brought this up. And it made me think this is a good topic to go over because it's a relevant thing. And again, it won't be at the time this comes out. It's going to come out in spring sometime. But it's still a relevant topic, therefore it brings it to mind. And I think now's a good time to talk about it, now that I'm thinking of it at least, and kind of putting on the docket of things that need to be spoken about. And it's just another sign, another one of these signs of the collapse. And in fact, I've been seeing this commercial lately that have been saying this is a sign of climate change, and it's been like something on fire and winds and like a hurricane tearing this sign apart. And all those signs say this is a sign of climate change. And it's like, you could do something about it. Go to Science Moms, whatever the hell that is. Maybe they're doing a good thing. Maybe they're not. I honestly don't know. I only say it just so that you'll recognize the particular advertisement I'm talking about. Maybe you can look into. I would not just go to that website and like believe anything that's being said outright. I would go to secondary and third party websites, see what they say about it, see what people are being saying, and see who those people are that are saying things, right? Look at whatever angle they have for talking about it, and things that they've said in the past to see if they're even reliable sources. But yeah, before you ever go to any place that's saying they have a solution, definitely check that out first. If it's a government site, I'd say it's more likely to be something that's okay. This, for now, right? For now. And by the time you get this, maybe not. So maybe I shouldn't even say that. Anyways, yeah, that's a whole other discussion. And it is a discussion that's definitely not a podcast topic. But yeah, maybe we can go over something like that in the future on a discussion, but we're not going to get into this on the podcast, and especially not on this particular one. So in talking about the cold, because he had brought up the polar vortex, and it got me thinking about that topic and the things that affect that and change that, and just wanting to get a bit more of an understanding of all the processes and what is really happening there. What's going on? Like, why is this thing changing? Obviously, climate change is the reason things are happening, but exactly what is climate change doing? You know what I mean? Not just is climate change. That's just too simple a question. Why is climate change doing this thing? What is it about climate change that makes this thing happen? But in order to understand that, first we need to understand what we're even talking about. And the first thing I want to talk about is the jet stream. And I think that plays an important part in a lot of this stuff, and I think it even mentions it in what's happening with the polar vortex. But even if it didn't, obviously these are processes in similar places. Like the jet streams going around, I think a lot of different places, but there's definitely like one in particular that's like the Arctic jet stream or something like that. And it has to do with the Arctic polar vortex that's being pushed down. So to me, these are integral systems. So a jet stream is a narrow band of fast-moving air currents that flow high up in the Earth's atmosphere, typically blowing from west to east, and are formed by the meeting of different temperature air masses, essentially acting as a dividing line between cold and warm air, significantly impacting weather patterns on the ground. So, first off, this is an AI overview, and I just asked what a jet stream is. Secondly, significantly impacting weather patterns. See, I don't. If you've been listening to me for a while, you know I'm not going to like this line. Significantly is, I know it's kind of a shortcut to say there's like a million things. We can't list them all here. We're just giving you a summary. But I think that's, I don't like words like that are just so interpretive. Like, what does significantly mean? Like, to the right person, significant is like one person. Like, if you have 100 people and one person has an aberration of any kind, whether it's a disease or a snaggletooth or just whatever, that is a significant danger to the rest of the population somehow, right? And we're not even talking like a communicable disease or something, because that's obviously always a significant danger to the rest of the people, depending on how contagious it is. But I'm just saying anything that's just different, regardless of whether it's a contagious thing or not, to somebody could be significant, even if it's 1 in 100, even if it's 1 in 1,000. This is a perception thing, so I never like these definitions. It gives a color, but at the same time, you can go with that and go like, see, significantly. Oh man, this is big, but what does that mean? Like if I look at it, I might be like, well, none of this is as significant as it's saying. Taken as a whole, I could see why they would call it significant, because even little bits add up after a while. But any one of these things isn't, you know what I mean? So, I just don't like things when it says just significantly and just kind of lays that out there. So yeah, it's basically a line of fast moving air, right? It says fast moving air currents that flow high up in the Earth's atmosphere. I don't know that part's even necessary. It's true, but it's, yeah. I mean, it's necessary in that I'm trying to find out what the definition is. But as far as just talking about it, the fact that it's high up isn't as important as it is a fast-moving jet of air that, in their words, significantly affects the weather patterns. You know, the fact that it's affecting weather patterns, the fact that it is a key in our climate topography, if you will, makes it an important thing. So so I want to know, okay, so there's a jet stream, we know what it is. So why? Why is there a jet stream? The jet stream is caused by the interaction of warm and cold air masses in the atmosphere. The sun's uneven heating of the Earth creates temperature differences between the equator and the poles, which drives the jet stream. Another AI overview, by the way. So this is basically just, updrafts and downdrafts, right? That create wind, and then you add in the Coriolis effect, and it's saying, I think the other one says it always goes from like west to east, and again, that's because of the Coriolis effect. So we're just describing wind. But the reason we get these jet streams is because we get the areas, the topography, and of course the uneven heating, like it says. So you get like the Arctic that gets the least amount of sun. And that the same with the Antarctica down there, the South Pole. So they're going to be colder regions no matter what. And because of that, they're going to form, they're colder regions. That's the word I was looking for. And of course, the equator is going to be a warmer region. Most of this is kind of a no duh. I think the thing that most people kind of glance over and don't really think about is that you don't have this gentle gradient. You don't have like 100 degree, then 98 degree, then 96, even if we're jumping by a couple, 94, 92, 90. You don't have that. You got like 90 here, but then you got 80 here, but then you got 70 here, but then you got 80 up here, and then you got 60 maybe, and then you got 70 again. So there's no gradient. It's just kind of all over. And then you get to a kind of termination line where it goes from like, 40 to like, minus 10 or something. And it's pretty significant. And that's why we get these jet streams, because we have such a strong cold, meaning, a significantly warmer, warm. And then it forms these jet streams. So it isn't, and of course, obviously the topography of the continents helps with that, with the updrafts and the mountains causing the updrafts, and they go up the sides of it. And yeah, so that helps shape the wind and helps shape where you're going to have more. Well, there's going to be updrafts. What am I thinking? High pressure. You're going to have more high pressure areas in some places more likely than others, just because of the way the wind is produced and the shape of the earth itself. So that is the jet stream and what it is. Now, the jet stream is having problems because it's being quote unquote blocked. So I have not read this yet, so I don't know what it says, but this is an article from carbonbrief.org, and it's going to talk about quote unquote blocking, but this is them quote unquote blocking. And I think it's important because nothing's actually like standing there like a wall, right? It's just kind of how they're looking at it that it's blocking. And they're going to talk about what climate change is basically doing to interrupt the jet stream. You can't stop the jet stream. It's not like the AMOC that'll just completely shut down. The jet stream could get weak for sure. It could get weak and very ineffective. But it's always kind of going to be there. It's really a matter of where it is. And where it is really going to influence where, like, for example, that polar vortex goes and why it's down significantly as opposed to higher up. So what we're looking at here is a little section called "What is blocking?" quote unquote. So we're going to read through this so we can get a better understanding of what blocking is and maybe climate change's effect on it and increasing it or whatever. Okay, so around the mid-latitudes of the northern hemisphere, low-pressure weather fronts, which bring cloudy, windy, and potentially wet weather, generally move from west to east. These are carried along by the jet stream, a current of fast-flowing air high up in the atmosphere. The jet stream generally keeps a steady stream of weather systems moving across the Earth's surface. This means that any low-pressure system or intervening high-pressure system that brings clear, still, and sunny conditions will generally only linger for a matter of days before being shunted on by the next system. However, sometimes weather systems can get stuck in place for an extended period of time. This is known as blocking, explains Professor Tim Woolings, Associate Professor of Physical Climate Science at the University of Oxford. The Oxford Joint Chair of Met Office Academic Partnership, the author of a book on the jet stream. So he tells Carbon Brief, which is the website we're on. Blocking is a stationary and persistent weather pattern, most often an anticyclone, high-pressure system, that blocks the oncoming jet stream and storms. I believe an anticyclone is one that rotates the other way. So it isn't really like matter and antimatter in that it's the opposite thing. I think it's the flow that makes it an anticyclone. With high-pressure weather systems in the way, the oncoming weather is either deflected away or it too stays put. This can bring extended periods of constant weather. Okay. In terms of the weather you will get, this means that under high pressure, the weather will remain mainly dry and settled for a few days or perhaps weeks. However, if you are in the area where the weather fronts are, you are likely to get wet and windy weather for a long time. Blocking is most common in spring. It says is most associated with dramatic heat waves in summer and severe cold during winter. What's causing blocking? So how do these blocking weather patterns arise? There are several different mechanisms involved, in the balance between these seem to be different in different regions. In general, however, Rossby waves in the atmosphere are thought to be crucial. Rossby waves are giant meanderings in the jet stream that stretch across mid-latitudes. They are also known as planetary waves. Rossby waves are a natural phenomenon that form as a result of the rotation of the Earth. As they are a feature of rotating fluids, They are also observed in the oceans and in the planets. And in other planets, such as gas giants. Blocking weather patterns can occur when Rossby waves become amplified and or break. Amplified Rossby waves can be seen in a wavy jet stream. This tends to slow the east to west progress, and it potentially allows for blocking to form. As an example, an omega block is so called because it resembles the uppercase letter omega in the Greek alphabet. In this shape, alternating waves of high and low pressure form in the peaks and troughs of the Rossby waves, respectively. Okay. A block interrupts the prevailing flow of westerly winds, which typically brings in mild air during the winter and cooler, fresher conditions in summer. Therefore, it opens up the potential for more extreme conditions, depending on which type of weather system is over. It's going through a lot of stuff. But what is important to get out of this is it's basically telling us that, like, the bad stuff isn't so much going to get worse. I mean, it is, but that's not what this is saying. This isn't talking about that. The bad stuff is definitely going to get worse, and this isn't saying that it is or isn't. This isn't really talking about that. What it is saying is if you have bad stuff, rather than just moving through and being like, kind of typical weather as we would normally understand, where it would get hot, but then, next week you got cooling coming in, and then maybe it gets hot again, and maybe, rain, and it's going to get hot, and then it's going to stay that way for longer than normal. It's going to get cold, and then it's going to stay that way for longer than normal. So you're not just going to have like a week or a weekend of, snow and ice, and you're going to have to get to work, or maybe you have a week off or something. Well, we're saying it's going to last longer. You're going to have a month of that, right? You're going to have at least a few weeks of that, not just a weekend anymore. You're not just going to have, half a week of really hot weather, or a week. You're going to have a month, right, of really hot weather just from that particular instance. So this is trying to say that the bad stuff that comes is going to be there longer. And for those who are saying, yeah, but that means the good stuff will last longer. What good stuff? The stuff that happens is good because it changes, because it's moderate, because it's constantly in flux. Plants need sun. Plants want cool weather, they want water, and they want sun. But it's got to be transitory. It can't be, yeah, there's some water, but then the sun sits there for like a month and just dries everything out. The plants don't want that. So you're saying, okay, well, in spring, it starts to thaw out. The thaw then brings water, and then we get the sun, and the sun really kind of helps accelerate the growth. Yes, absolutely. The problem is the sun's going to stick around. It's going to be more intense, which means all that water is going to get evaporated a lot quicker. The plants aren't going to get a chance to utilize it all, and the sun's going to be intense in a way that the plants aren't going to be able to handle it, which means, no, it isn't more good. It only brings more bad. It also brings more good. Bringing more of something is always bad. Remember, everything in moderation. This is talking about not having moderation. Now, this isn't saying everywhere on Earth it'll always be hot there now forever. It'll always be cold there forever. It's just saying these temperatures in the extremes, which is happening more and more, that we're getting these extreme temperatures, are going to last longer. So when it's hot there, and you're like, well, this is great. It's summer. We want it to be warm. We want to get out and do these things. Yeah, but now it's going to be worse hot. It's not just going to be nice, warm, get out, get into the, lakes and reservoirs and have a good time. It's going to be, you're out in the lakes and reservoirs with the water on your body, acting as tiny little prisms all over, amplifying that sunlight. All suddenly people are going to get burned more by being outside and doing these outdoor, water activities that normally you would do to cool off and get the evaporation going and the wind going by. Now these things can be more dangerous than helpful. Like, it starts turning all your good things bad. Not, okay, we can have a lot more bad stuff, but also a lot more good stuff. A lot more is just bad, right? There is no a lot more good stuff. And you say, well, how about the rain? Yeah, it's called flooding. We just went over that. We don't want more of that. We want the right amount. That's that's the adaptation that our planet has gotten to. It's not a living organism. I know a lot of people like the Gaia, thought where the entire Earth is basically just one living organism. If you want to think of it as a complex living organism, the same way that we are, where we're just a set of systems that work together, then yeah, you could think of it like that. But there's no nervous system, there's no central nucleus, there is no deciding, I'm going to move my arm or I'm going to wiggle a flagellum and go and get some food. This isn't really a giant organism, all right? But it does adapt. The plants that grow that move into that area adapt and diversify. There's there's adaptation that happens, but this is going to go beyond that, and the problem is that the adaptation won't be enough. This is going to heat up the entire area and just burn. Well, it's going to burn things to the ground because of fire, but even if it doesn't produce fire, it's going to burn the plants. They're going to get overheated. The moisture in their leaves are going to get all dried up. There's going to be no more active chlorophyll. Like there's not going to be any more good stuff. It's just all bad, right? We want things to move. We want moderation. We want things to kind of always cycle and have a decent cycle. The planet's used to things being a certain way. The animals and plants have adapted to the desert. They've adapted to the rainforest. They've adapted to this. And once these start changing, those adaptations no longer do them any good, and they start dying off. It's not an equal battlefield here. It's not a more sunlight equals more life because plants like sunlight. More carbon dioxide equals more life because plants like carbon dioxide. That's just not the way it works. These plants and animals have already adapted to Earth the way it is. They're slowly trying to adapt to the things that we're doing. Some of them aren't going to be able to or not going to be able to adapt in time. The biodiversity on our planet is what saves it. So when I just saw a conference the other day talking about the fires, doing cuttings, thinning out the forest, creating these sort of fire blocks. And somebody was complaining. I'm not going to name names because I don't want to get in a big political BS thing here, right? I mean, I think the politics of me and the show are fairly obvious, but I don't need to go into a bunch of triggery stuff and have you not hear what I'm trying to say because of how much you're just yelling about how dare you, blah, 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 right? Because I don't care to be like offensive and be straightforward with that, but I don't want it to take away from what I'm actually trying to tell you, and then you get off on this other tangent. So they were talking about thinning and getting fire blocks, and then they were complaining that environmental groups were saying, hey, you're cutting down habitat. And the response was, yeah, this is stupid. We need to stop them from being able to do that. In the small-mindedness of these people and what it means to get rid of habitat, that they only see 2 feet in front of their frickin' face is embarrassing and terrifying. Anyways, yeah, so that was a fun little tangent. So then we're talking about these developed areas where something just kind of sticks around. And so one of these is called a heat dome. And we had one of those here in my area. I believe we had one last year too, but it wasn't as bad. We had one a couple years ago that killed like 2 billion I don't know if it was individuals or what it was, but it's like 2 billion animals or something in the ocean in the tidal areas, which anybody who knows anything knows that the reefs in the tidal areas hold the greatest diversity of marine life in the entire ocean. So, heat dome is a weather phenomenon that traps hot air in a region, causing extreme heat. It's created by a high pressure system that stalls over an area, preventing warm air from rising. And it stalls because of what we were talking about before about the blocking. And this ends up causing a stall. And when it's this high pressure area, then that's going to cause this heat dome. So, this is one of those things that we're talking about with the jet stream and what it's going to cause. One of these things is going to be a heat dome. So on to what started the whole journey for me, the polar vortex. The Arctic polar vortex is a band of strong westerly winds that form in the stratosphere between about 10 and 30 miles above the North Pole every winter. The winds enclose a large pool of extremely cold air. There is an even stronger polar vortex in the southern hemisphere stratosphere in its winter. The stronger winds, the more the air inside is isolated from warmer latitudes and colder it gets. So, according to NOAA, stratosphere expert, people often confuse the polar vortex with the polar jet stream. But the two are completely separate layers of the atmosphere. The polar jet stream occurs in the troposphere at altitudes between 5 and 9 miles above the surface. It marks the boundary between the surface air masses separating warmer mid-latitude air and colder polar air. It's the polar jet stream that plays such a big role in our day-to-day winter weather in the mid-latitudes, not the polar vortex. The polar vortex doesn't always influence winter weather in the mid-latitudes. When it does, however, its effects can be extreme. When the polar vortex is especially strong, for example, the polar jet stream tends to stay farther north and exhibit a more zonal flow with less meandering. At the surface, the stable stratospheric state is often associated with an even colder than usual Arctic and milder than usual weather in the mid-latitudes. The Arctic oscillation, which tracks hemispheric scale wind and pressure and air pressure patterns, is often positive. By the way, this is on climate.gov. At the other extreme, the polar vortex is occasionally knocked off kilter when especially strong atmospheric waves in the troposphere, and I think those are those Rossby waves, is what it's talking about. In the troposphere, break upward into the stratosphere. The vortex slows, and it may wobble, slide off the pole, split into several lobes, or, in the most extreme cases, temporarily reverse direction. Regardless of their quote-unquote flavor, these disruptions have one thing in common: a spike in the polar stratosphere temperature, which is why they're called sudden stratospheric warmings. I was talking about February 2021, when there was a really big cold snap, and that's when Texas was getting a lot of freezing, and I think their power grid went down for a while. Texas just everybody who moves to Texas is crazy, man. But Texas has just been getting hit a lot with floods and extreme icy snowstorms and everything. A lot of things you don't normally associate with Texas, or didn't before, anyways. Right? So yeah, I remember that, and their power grid is constantly going down. Why is that? Because it costs some money to update the infrastructure, and they're all waiting for the government to give them that money, while the Republicans are constantly telling people how we should have smaller government, not giving money to things like that, because those things help people, and they don't want to help people. They'd rather subsidize weapons and war and things like that, which gets their friends all the money. So, yeah, they're more part of a discussion than the podcast, but yeah, this is just part of the problem when it comes to when people lose their power. There's pluses and negatives to having buried lines, right? I know I've seen a lot of negatives as far as maintenance. It's tougher, although there are ways to circumvent that and make it easier under there than it is. We have better materials and methods of manufacturing that make burying the lines better than it used to be. The thing is, it A, gets the lines out of everybody's faces, and you could just go back to looking at nature in a lot of places where there's just giant lines everywhere. And it also makes it less susceptible to things like fire and floods. And notice I said less, not susceptible. That's not what I said. I said less susceptible to those things, especially if they're not quite as intense. I mean, if something's intense enough, it doesn't matter what you do. Things are going to go down. And it also depends on how far down you dig those lines, right? But especially with major power lines, having a tunnel, like just a 2-story down tunnel, and goes through and has all the sewer lines and everything where people could just go into the tunnel and maintain those things, that would probably be a good idea. These things would take a really, really long time to install for like an entire planet, right? But things like that could really help in the long run and really protect us against things like X-flares, which would cause massive disruption to our power grid because they're not hardened and they're just exposed out in the air. Just, hey, come and get me, right? So that's talking about that. We already went over the Omega block, so I won't go over that again. A couple of little more side notes is something that I had. Each one of these was an entire podcast. It could be again, but I think it's better just to kind of throw them in here. We're talking about the weather. We're mostly talking about the cold and why it's driving these extreme colds, but also hot spots. Obviously, we're talking more about the cold right now, but it does both, right? But when we're on this subject, I think it's good to bring a couple of more fun little tidbits. So there is something called a sting jet. I'm just going to read the Wikipedia description here on what a sting jet is, and it's going to tell you. A sting jet is a narrow, transitant, and mesoscale airstream that descends from the mid-troposphere to the surface in some extratropical cyclones. When present, sting jets produce some of the strongest surface-level winds in extratropical cyclones and can generate damaging wind gusts in excess of 50 meters per second, I think is what it's saying. Yeah, because it says 110 miles per hour, which that's more what we usually hear it as, at least here in America. Sting jets are short-lived, lasting in an order of hours. In the area subjected to their strong winds is typically no wider than 100 kilometers, making their effects highly localized. Studies have identified sting jets in mid-latitude cyclones primarily in the northern Atlantic and western Europe, though they may occur elsewhere. The storms that produce sting jets have tended to follow the Shapiro-Kaiser model of extratropical cyclone development. Among these storms, sting jets tend to form following a storm's highest rate of intensification. So if you look at at a storm, you'll see a little, sliver kind of develop, and it looks a little bit like a stinger or a sharp little point in it, but it's also curved because, the tropical cyclones are, like giant hurricanes. But, usually in another part of the world where they call them cyclones as opposed to hurricanes, as opposed to typhoon. That was the other one. But you'll notice that there'll be this little small, it looks like a little stinger, right, inside the actual storm. It's easier to see on like a like a satellite image that's not looking just at the clouds, but is looking at like the precipitation, right, or the wind intensity, and that's the models where you'll usually see that little stinger, like, and so they call it a sting jet because it resembles like the stinger on like a scorpion or something. And it's the area that's the most intense part of the storm, which is kind of the important thing. And we've been hearing a little bit about this lately, but this is something that we've heard a lot about in recent times, in the last, like, say 10 years or so, right? I hadn't heard about this until maybe 5 years ago, when I really started getting into the podcasting and doing this kind of thing and learning this stuff. Um, Another one, I did a whole podcast back in the day on just this, but in this particular new form, I think it's better to just add it on. It's kind of a neat little tag to this one. And that's what is known as a bomb cyclone, right? And it's not a bomb. The bombs have nothing to do with it. The bomb is just kind of a explosive thing. It's explosive in it's a kind of a sudden, right? That's where the bomb and kind of in bombs. I don't know if it's going to say, oh, this is a no, because this isn't a Wikipedia. I mean, it still might say, but this isn't a Wikipedia article. This is AccuWeather.com, where I'm getting this about the bomb cyclone. So we often hear the storm system is undergoing bombogenesis, or more simply put, is developed into a bomb cyclone. What exactly does that mean? In simple terms, bombogenesis or bombogenesis, a term used by meteorologists, is a large storm that undergoes rapid strengthening over a 24-hour period. The vast majority of storms occur over the ocean. The storm can be tropical or non-tropical. So let's see if it actually... the term bombogenesis comes from the merging of two words, bomb and cyclogenesis. Bomb refers to the explosive development, and altogether the term means explosive storm strengthening. Yeah, so there we go. So it does mention that. I'm trying to find where it's... Oh, here we go. Average storms in the winter have a low barometric pressure reading, 29.53 inches of mercury. Most intense storms are below 29 inches. But it's not the lowest pressure that defines bombogenesis. Okay, here we go. This is good. When the barometric pressure falls at least 0.71 of an inch of mercury, or 24 millibars, which is usually, I don't know why they're doing this mercury crap. When you listen to the news, I personally, and this may just be an American thing, I've never heard them mention inches of mercury. In fact, that should be an outdated thing that nobody mentions, because mercury is extremely dangerous. We shouldn't have it just in our houses just so we can tell temperature. We have way better ways of doing that now. We don't need that. But 24 millibars in 24 hours is what it's saying. So the pressure falls at least 24 millibars in 24 hours. When it does that, it has become bomb cyclone. And then it goes on to talk about some bomb cyclones. So when you hear bomb cyclone, there's no explosions happening. There's no bomb. The bomb is just the quote-unquote explosive nature of how quickly it's happening. It's a more measure of speed. It's a bomb cyclone because something's happening fast, like an explosion, right? So, yeah, it's when it drops 24 millibars in less than 24 hours. And that's something you have to know. You have to pay attention to the barometric pressure, the official barometric pressure, not your particular one outside, right? If you're paying attention to that or just listening to the news and you hear bomb cyclone, I don't want to say don't freak out, because it means it's going to be a bad storm. But the fact that it has the word bomb in it isn't specific to the storm itself, other than its development. It's just developing really quickly, which could also be really bad, because that means you're going to have less warning that is happening, right? Ice age, like what were temperatures in the last ice age like? The last glacial maximum, which is just fancy word for ice age, was around 46 degrees Fahrenheit or 7.8 degrees Celsius. And this is an average. This isn't like the lowest it's ever been. This is just an average. So 7.8 degrees Celsius. And we're at 14 now, or 14.5. Well, we're not at there now. But what I mean is our average outside of, the ice age, not accounting for global warming, is like 14.5. 14.5 somewhere, in that vicinity, depending on who you're listening to. If they want to, I don't know if they just drop the 0.5 again because it's easier and more of a round number, or if it's always been true and they just don't, you know what I mean? So somewhere in there, anyways. So not quite double, right? Not quite double, but pretty close. A significant margin of a doubling since the Ice Age. So those are temperatures that the Earth has gone down to during the Ice Age. And to me, that's interesting because it tells us what extremes that the Earth has gone to as far as cold goes, but we don't really get much warmer naturally than we are right now. And if people are thinking, well, that's good, right? That means we're still in the pocket. Naturally occurring, yes, you'd be right. We're in the pocket now. We're in an extreme of the pocket, right? Even the pocket, one end or the other, is extreme. When you go down to 7.8, you're in the Ice Age. This isn't like just a normal, I can get to. This is like, yes, life exists in that. It's kind of a normal process for the Earth, but it's still an extreme part of that process. We're at an extreme other end of that process with the heat. It is part of normal in the past. The past has gotten to be this warm in the last, I don't know, since hominids have been on the Earth, I think, is what we're looking at. It's gotten somewhere around here, right? And that's it. Like, we need to then back off from this to keep our normal window of what it's like on this planet. And again, that's without human intervention. That isn't, okay, but now we just did it and did it quicker because we did. No. We made it worse than what it should be now. And then if it naturally gets up higher, sorry, I should take a drink. So if it naturally gets higher for one reason or another, now we're adding the human intervention on top of that, which is already an extreme heat. Again, just because it's in this normal window doesn't make it not extreme. But we're reaching now the extreme of that and maybe reaching a little outside. I don't remember what the range really is. I think it's 1.5. It might only be 1.3. I honestly don't remember. I think it might be 1.5. What it isn't is 2. 2 is too far, right? I don't know if it's gotten up to or close to 2. I honestly don't remember the range. I do believe that it's never gone above 2, though. It might have gotten to 2, actually, now that I'm thinking about it. I'd need to go in and look that up again. So even if we cap it at 2, this is still getting into the extreme, right? And again, I want to say this one more time for people in the cheap seats. Under normal conditions, with the Earth by itself, without our intervention, that's the kind of temperature we're talking about. And that is an extreme, right? It's not a normal, it's an extreme, but it's still within the normal window. And so that's, and again, this is including things like ice ages. Including ice ages and including extreme heat events. This is what we're looking at. And if this was done just normal, then it would still be within the normal range of what happens on Earth. But because it's not normal, we're pushing the normal bounds on top of what the Earth itself might do, which makes it even worse. And again, what we're talking about is stopping right now, boom, period, done. We're still going to see significant problems in the future of what's happening. Even if we stopped right this second, we still got a lot of problems coming our way. But we're not stopping, and we're going to make it worse. And that's really the crux of the issue. But for now, we'll just call it here, and we'll see you on the next one. Will we survive our own apocalypse? Only time will tell.